Here's another question about quantum numbers. When they give us some designation, if they're specifying a valid sublevel, and the key here is if it's valid, because sometimes they can try to trick you and give you an invalid set of numbers or designations. An S sublevel, any valid S sublevel, has one orbital. Any valid P sublevel has 3 orbitals. Any valid D sublevel has 5, Fs have 7, Gs would have 9, Hs have 11, so on and so forth. Theoretically, there is no limit. Now, some of these designations name a particular orbital within a sublevel. And as long as that name is valid, and to know that you'd have to read Chapter 7 carefully, because there are some valid names. I don't think they're trying to trip you up on whether any given name is valid or not, but there are a set of valid names, and they're all solutions to Schrodinger's wave function, which specifies a region of space where there's a high probability of finding an electron. The other thing that's important about this problem that will distinguish it from other problems in this WebAssign is they're asking about number of orbitals. They're not asking us about number of electrons. For any valid orbital, you can have up to 2 electrons in it. But in this question, note to bene, there's only the number of orbitals that they're asking for. Okay, let's start with the first one, 5p. Is 5p a valid sublevel designation? You betcha. The angular number associated with a p sublevel is a 1, and that's definitely within our range of 1 less than the principal number. So yes, that's good. P sublevels have 3 orbitals within them, so I'm going to write down 3. Next one, 3dz squared. Is the 3d sublevel a valid sublevel? Yes, it is. In angular numbers, you can have 1 less than the number that's equal to the principal number. So you could have up to 2 for the angular number. Well, angular number 2 corresponds to a d sublevel. So yes, that's valid. And then z squared, that actually specifies a particular orbital within the d sublevel. Yes, any d sublevel has up to 5 orbitals, but this one is specifying a particular one of those, so only 1 orbital can have that designation. The 4d sublevel, is that valid? Yes. The angular number that corresponds to a d sublevel is 3, and since that's within the range of 1 less than the principal number, that is valid. They don't specify which particular d sublevel, so up to 5. 5 orbitals can have the 4d designation. Okay, the last two just specify a principal number. Well, goodness, there are lots of sublevels in the 5th principal energy level. There's the 5s sublevel, the 5p sublevel, the 5d sublevel, 5f, even 5g. How many orbitals are valid in each of those? Well, you could have 1 in the s sublevel, and we're going to add these together, and 3 in the p, and 5 in the d, and 7 in the f, and 9 in the g. If you add all those numbers together, you get 25. 25 orbitals can fit within the 5th principal energy level. How about the next one? N equals 4. Well, what sublevels do we have? 4s, 4p, 4d, 4f. The number of sublevels is equal to the value of the principal number. How many orbitals are there? In the 4s sublevel, there's 1. In the 4p sublevel, 3. In the 4d sublevel, 5. And in the 4f, 7. If you add those together, you get 16. Now, students, it's not an accident, if you're watching closely here. 25 is 5 squared. 16 is 4 squared. The number of orbitals in any principal energy level is equal to the value of n squared. And that's the case for all of the principal energy levels.